All right, let's go ahead and look at this second problem. I know I went away for a little while there, so that's why you've got a different problem because I called it up. Um, Again, there's the solution to 9 if you need it. But so the speed of a proton that has the same momentum of an electron. Again, we're going to take advantage of the rest energy and just do a bunch of algebra. All right. And following the physics and mathematics is the tool of doing physics, and so we're going to do some. It's not crazy algebra. It's just what you'd expect in a good algebra 2 type class or something like that from high school. When will I ever use this stuff? You're going to use it now. Okay. All right. So here we go. We got find the so if the if the electron speed is 0.85 c, what would be in its momentum, and then what would be the momentum of what would be the speed of the proton with the same momentum as the electron? Okay, well, first of all, so let's just get started. So we got V equals, in this case, let me get out a better pen. That one's dying. So get V is equal to 0.85 c. And this is, again, this is the velocity of the electron. Okay, so maybe I should call up what I'm doing. There we are. Now we got it. Okay. All right, so here we go. And here's the deal. We want to know, first of all, let's take a look at just relativistic momentum. It's gamma times mv. All right? It's gamma times mv. All right, so here's a little trick that we do. Okay, here's a little trick that we do. Well, we know that the electron has a rest mass, right? Okay, so if we can do gamma times mc squared times v over c. Like that. Okay, so it makes this v over c, like that. Okay, all right, and so what that gives us is, that's just a little trick. Notice what we're doing. We wind up with echo naught times beta over c. All right, and that's beta of the electron, and this is the of the electron. Okay, and this is the gamma. All right, so the same thing is happening over here with, so that was a little trick that you wouldn't have known to do. So there you go. The rest is just dibbling. There's the little tricky physics part, and now the rest is just dibbling and scribbling. Okay, so if now we're going to take the momentum of the proton, and I'll just walk it down this, and we're going to wind up doing the same thing. We got gamma of the proton. I could call it gamma proton instead of putting a slash there, times echo naught of the proton times beta of the proton over c is equal to gamma echo naught of the electron times beta of the electron over c. Yay, the c's cancel. That's nice. And look what we have here. We've got a number. We have a number here. Okay. We've got a number. Not yet. I've got gamma p times beta p is equal to gamma of the electron. Let me put the electron in there. Times echo naught of the electron times beta e of the electron divided by the rest energy of the proton. Now you have a number. because you can calculate this. This is the 0.511 mega electron volts. This is the 938 mega electron volts, and this is beta E is this equal to, in this case, 0.850 C, 0.850. V over C. It's just a number. Okay? It's the 0.85. Because that V is this times C, and then it's over C, so the C's cancel. So it's just good old 0.85, what that equals, and for this problem. And this is, so you got everything you need. Got everything you need. Now then, let's go about solving this. All right, real quick, I'll give you a head start here. So we've got to look at beta P over square root of gamma P squared over 1 minus beta P squared. That's what we're after. Sorry, I started to put the gamma function. This is the gamma function. This is beta times the, so beta, the gamma function times the beta function looks like this. All right, and that is equal to that big number that we, block of numbers that we got before. All right, from this guy. Computer. So be careful when you do it. Be careful when you do it. Go ahead, make sure you get this one first. Multiply by that, and divide by that. You got it. All right. Now then. So here's how we solve this. So we got beta P is equal to the block of number times the square root of 1 minus beta P squared. All right, we only have one unknown. I mean, we only have one variable. It's just, we got to do some algebra tricks here. Square both sides of the thing. So we get beta P squared is equal to gamma of the number squared times 1 minus beta P squared. Correct? All right, so here we go. So we're going to do this. We're going to go ahead and take this number squared times 1 minus this number. I want to square it like this. This number squared times beta P squared. We're going to add that over here. Okay, so we're going to come up with that number squared times beta P squared plus beta P is equal to that number squared. Yay! Little algebra, that's all we're doing. Let's factor out the beta P squared equals that number squared plus 1, all in parentheses like that, which is equal to that number squared plus 1. We multiply it by beta P squared. Okay, I don't know why I said plus 1. I was getting ahead of myself there. We good so far? Make sure to put a square on that. And so beta P, when it's all said and done, is equal to that big old fat number squared over 1 over that number squared plus 1, taken to the square root. I don't think you all signed up for that. But I mean, that looks crazy. But I just when I was trying to do it with my calculator and everything, when one of your classmates asked on the I need help with the thing, with his homework, I looked at it. I thought I assigned something much more straightforward, but I'm glad I got this one. Is something like this on your file? No, not even close. All right, so I'll print those off, send them to you, and we'll make a thing of it. All right. Well, two announcements. What we're gonna do. All right, out here. Good luck on your final. You're gonna be great.